Thank you, Ken. Appreciate the introduction. Good morning. Welcome to the 10 Commandments for Successful Porous Asphalt Pavements. As introduced, I'm Mark Palmer, a Senior Civil Engineer for Sound Transit. Over the last 30 years or so, I've designed, constructed, applied lessons learned on dozens upon dozens of porous pavement projects. I want to share some of those lessons learned with you, some of which were trial and error, so that you don't have to experience that the hard way. And most importantly, ensuring your installation will be successful. Nothing hinders porous pavement adoption than unsuccessful installations, and I want you to succeed. We only have 15 minutes on a topic that I could talk all day on, so let's get started. This is going to be fast-paced. Okay, clicker's not working, but there it goes. Okay, now we got it. Sorry about that. Well, you're first probably thinking, why would I want to use porous asphalt pavements? We have the tried and true standard impervious pavements, so why go to this new and different way? That's a fair question, and let's take a look at some of the benefits first. We could spend an hour on each of these benefits, but we'll have to save that detailed discussion for another day. So porous asphalt installations are efficient use of public funds because they cost less to install. Now, I'll mention that this is when we're comparing impervious asphalt roads and stormwater systems against integrated stormwater porous pavements. A couple examples is one for the city of Tacoma has experienced a 30 to 80% savings when installing porous asphalt on some of their projects. For one project I completed, I avoided over $300,000 in real estate cost alone by avoiding the need for a stormwater pond on commercially zoned property. And by avoiding that pond construction, that site has now beneficially been used as a senior retirement community instead of a stormwater pond. Porous asphalt's easier and less costly to maintain than impervious asphalt. I always get raised eyebrows on this one. But impervious asphalt fights the losing battle against water intrusion with maintenance activities like crack sealing, pothole repair, chip seals, and overlays. Porous asphalt, however, only requires a periodic grinding and overlay. And for those of you listening carefully, you may have noticed I didn't say potholes. So, porous asphalt with the current state-of-the-art embodied in the 10 Commandments you'll hear today has a similar life expectancy as porous asphalt. Thus, with the same service life but less installation and maintenance costs, porous asphalt can stretch out thin street and stormwater budgets. This sounds pretty good, right? This is going to sound like some TV commercials, but wait, there's more. Go. Porous asphalt has less glare, road spray, and a higher coefficient of friction in rain events. Guess what? That makes it safer. Texas has conducted some before and after studies of their open graded friction course installations on freeways. They noted significant reductions of accidents on those roads. If anybody's a stormwater geek out there like I am, this is where we get excited. Porous asphalt provides significant water quality treatment, even for that 6 ppdq. And that's covering most pollutants that we have. Porous asphalt also provides an efficient flow control by infiltrating through the subgrade of the pavement. Widespread use of porous asphalt reduces the urban hydrology impacts to streams by providing greater base flows to those streams through groundwater recharge and reducing stream temperatures. So now maybe you're pumped up, you want to go start using porous asphalt pavement, but where do you start? You start with recognized standards that have been successfully demonstrated. Texas has some standards that are very similar to ours, and there may be others out there. For Washington State, a group of engineers, owners, suppliers, and industry representatives published the first APWA specifications for Washington. There's a link to the specifications as they're currently standing. This is a great starting point for your journey into porous asphalt. But even as we were putting these together back in 2015, 2016, we were continuing to advance the practice of asphalt pavements. and I'll share some of those advancements here today. It is on my to-do list to get the band back together so we can review and revisit these standards, and hopefully that'll happen soon. But the specifications can't and won't get you all the way there. There are also some key design considerations to successful porous asphalt installation. This slide just shows you some of the organizations that were involved in the effort to produce the specifications. At this point, I was representing the city of Puyallup in this effort. It's a good time to mention that the focus of this group was to create a durable, rut-resistant pavement that would provide a similar service life compared to impervious asphalt, and being less concerned with the drainage performance. As we already covered, impervious asphalt tends not to be impervious over time. It's not too much of a leap to think that porous asphalt will have a similar trend over time, and drainage should be less of a focus. So here they are. We're going to go over the 10 Commandments. Number 1 on the list, and it's there because it's important, and it's also one of the most violated elements of porous pavement design that I come across. Porous asphalt is a great filter media. However, it can be overloaded by sediment-laden flows coming from adjacent surfaces. These flows will pass over the pavement while leaving a layer of sediment behind. There's a great example of this at the WSU Puyallup LID Center, where flows from an adjacent dense graded pavement flow across porous asphalt, and you can watch the pavement clog over time, slowly going further and further down the pavement. As a result, WSU has to power wash this regularly in order to keep it well draining. There's many ways to address this. Interceptor drains, extending a reservoir course to the surface outside the pavement to intercept them, different grading to avoid run-on, the list goes on. One of the most common and misguided abuses I see is in parking lots where aisles are made of impervious asphalt graded to the porous asphalt. Usually this is based on unfounded concern about wheel turning moments at low speeds. Again, if you follow the commandments, this won't be a concern. Kind of a corollary to number 1 is, even though you can grade much flatter grades in your designs with porous pavements, you should still be grading that to a positive drainage course, get into the extended reservoir course, interceptor drains, catch basins, as a redundant route for drainage. Ideally, the redundant drainage will be routed to the reservoir course and infiltrated into the ground. Use of a polymer-modified asphalt. This is a key to success, and this is a very important one. The polymer-modified asphalt sticks to the aggregate better and longer. Porous asphalt, because it requires less maintenance, will be exposed to weather and sunlight UV rays for much longer than a dense graded pavement. Excuse me. There are also less fine materials in porous asphalt to hold that asphalt up in place, so this higher grade of asphalt helps compensate for that. For similar reasons that why we use a higher grade asphalt, we also use more of it. And you can see here that's 6 to 7%. Impervious asphalt is usually somewhat less than 6%. Just as a note from experience, there may be some resistance if you're working with a supplier that hasn't produced porous asphalt before on meeting this standard. But you'll need to stick to your guns on this one. It's here for a reason. I can't overstate the importance of this one. Inclusion of fibers is critical to the mix design. One of the reasons is similar to the asphalt grade and percent content. The fibers help span the gaps in the voids of the asphalt, allowing more connection points without seriously compromising the permeability. The most important reason, however, is greatly increased rut resistance and durability. And we'll talk about that in number 10. Of all types of fibers seem to perform well, improving rut resistance. However, recycled asphalt shingles perform well, and at least in this area, you can get that for little or no cost. You can see here some of the results from the Idea School in Tacoma, and they do show that the RAS, or recycled asphalt shingles, as having an infiltration rate less than the 200 inch per hour specification, and that's what we had said in those standards as well. But it's been performing well. And trying to put that into perspective, keep in mind that this region has a 24-hour, 100-year storm event somewhere around 4 inches, or about 0.17 inches per hour. An infiltration rate, such as shown here for these pavements, that's 3 orders of magnitudes higher than that should be sufficient for drainage. This is another big improvement that needs to be incorporated, and this comes from Jessica Knickerbocker, City of Tacoma, is one of the members of the committee. In the past, there had been issues with the use of traditional choker course aggregate installed between the reservoir course and the porous asphalt. It was difficult to get the aggregate gradation to the correct point where it would lock in the reservoir course and allow the construction equipment not to sink and heavily rut into the section during paving operations, which was very difficult. Use of the porous asphalt treated base addresses this very effectively. It even allows traffic on the porous asphalt treated base before paving the porous asphalt, and its bonus, the porous asphalt treated base provides a greater structural strength to the pavement, which is one of the ways it allows us to utilize porous asphalt on higher volume roads. I'll emphasize this point, there should be no designs out there using the old choker course design standard for a section. If you see it, change it. For a number of reasons, I'm even considering taking the potential step of just removing the reservoir course altogether and using a straight porous asphalt treated base as the entire section, making it a 2-layer system. Compaction. This one is, again, they're all important. That's why they're all on here. But another critical application of a lesson learned, dating back to the initial porous asphalt installation clear back in 1977, too much caution was used in compacting porous asphalt pavement out of concern that it would become insufficiently porous. This one practice has been a hard one to counter. Our goal has been to produce and install porous asphalt as close to impervious asphalt practices as possible. A well-recognized standard for impervious asphalt has been to compact to 90 to 92% of maximum density to achieve higher performance. Porous asphalt, because of the voids, cannot meet that, but we have settled on an 80 to 85% max as an achievable goal. So way down to number 8, and it's down below one for a reason, we finally consider the permeability of the pavement. We do that by setting a voidage content of 16 to 25%. The lower end of the scale is fully adequate for drainage through the pavement section. If you have your mix design at the upper end, you may want to look at lowering that just to get it down a little bit. Drain down, this one's going to probably be foreign to most people, but put it simply, it's just a measure of how much asphalt is coming through the sample puck during the testing process. It's a very small amount, but if you're following the rest of the commandments, this one should be successful without too much difficulty. The higher grade asphalt and fibers also assist in passing this test result. And just note, in field construction, if you're watching porous pavement installations, if you're seeing a lot of asphalt in the beds of trucks as they leave, you may want to pause construction and check this test again because you're getting too much drain down. Final one is passing the Hamburg test. So Hamburg test is a wheel rolling test that places a puck of compacted mix, compacted to that 75 gyrations, in a warm bath of water and passes a steel wheel over it 20,000 times. If the material deflects less than 10 millimeters after that, it passes. This test is definitely predictive of rutting resistance in pavement and is critical to assuring that you have a durable pavement mix. While a mix designed without fibers can pass the test, but not always, the mix will have a much better chance of passing with fibers in the mix. So here you can see one set of test results, and you can see that the one without fibers actually performed and passed, but the ones with fibers still performed better and had lower rut depths. Going into the bonus optional commandment, consider using warm mix additives in your mix. So the warm mix will allow for a wider range and easier compaction of the porous pavement, so you can meet that one standard for compaction. And since warm mix is placed at a lower temperature, it's better for the workers. They don't have as hot of asphalt to be standing on, and it helps reduce the air pollution emissions. So that is it. Looks like I'm about right on schedule. I want to thank you for your time and interest in porous pavements and this whirlwind introduction. I am more than willing to talk about porous pavements at any time for any length that you have available. So come get me. I'll talk. I'll be out in the hallway if you have any questions. Thank you, and have a great conference.